Okay,
Wow.
everybody direct your attention to the calendar. Today is the 18th, so we are here. We've got 9 school days till spring break.
Oh. Yes! 9 days till I don't, never
Beautiful
mind.
weather over the weekend. I don't know about y'all, but it made me want to go ahead and have warm weather. But then again, I'm like, no, I can't stand bugs. So there is a cold snap tonight. Low is 28, so heads up. Which is good, because we definitely need some bugs to die. 7.4 will take us 2 days. 7.5, I need to double check. I don't even want to speculate. But then we'll have 7.5. Then we will
The rest of them.
go over the mid-chapter exam mistakes so you can learn from them. And then we will review for the end of Chapter 7 exam.
Which is
I will give you more
20.
details on the end of Chapter 7 exam the day I hand you the review. Because I need to, y'all know me, I'm always reflecting and thinking, changing stuff. And I need to see how the mid-Chapter 7 exam actually ends at before I reflect on the end of Chapter 7 exam. We are looking to take that exam the 27th or 28th. I don't know that it's a 2-day exam because the end of Chapter 7 exam focuses more on the end because you've already had an exam over the mid, right? So there'll be a couple of elements of mid in there, but the majority of it's the end. And I think you're going to actually appreciate the end of Chapter 7 exam more than the mid. The mid's usually the most stressful one. When we get closer, remind me, and let's get that done before on the 27th. So
Can we
then
just
I'll
take it on the
shoot for us
27th?
to be ready by the 27th.
Can we just all take it then?
It depends. Let's
Okay.
reassess it when we get closer. And then, of course, we have spring break, and then we have Chapter 8. Chapter 8 is 6 sections long. It is dense. It is law of sines, law of cosines, solving triangles for missing sides and angles. It is what a lot of people enjoy the most, but it is a lot of information because there are numbers.
Yes!
Taylor. There's numbers.
There are numbers in this one too.
And then we will, of course, as we're getting through Chapter 8, we'll talk about when our tentative date for the final exam will be.
The 30th of April.
We have plenty of time to space Chapter 8. We don't have a lot of time to space the end of Chapter 7 out because we're looking at the deadline of next Thursday. Okay, so if you're sick between now and next Thursday, just coordinate with me. If you're not sick, then just try to be here so that so you don't have anything hanging over you over spring break, right? I don't want y'all doing any math over spring break, and I don't want to do. I'll have to do I have papers. I got to work on my papers.
I'll catch up on Chapter 6 homework.
All right. Pretend like I didn't hear that. All right. Please go to 7.4, guided notes. If you have colored markers, pens, or highlighters, you're going to want them to take some notes. These first 2 pages, or these first 2 slides of information, have a lot of information on them, and I color coordinated it so that it'll stand out in the right way.
One pen. Jail. And.
All right. What? 2. 2 should be good. Maybe even 1 would be fine.
Boys up.
Okay, real quick refresher. So this is from our college algebra class. I'll put recall. Let's see. We're going to draw the mother function for a parabola. The mother function for a parabola. And now we're going to refresh your memory on what was called the inverse of a function. The inverse meant you took x and y and you switched them, and then you solved for the new y, and then you wrote the function. The fancy notation for inverse was f little negative 1. Remember that? What is the opposite of squaring? Square rooting. So the inverse of x squared is the square root function. Graphically speaking, the inverse is when you take a graph and you reflect it over the line y equals x. You reflect it over the line y equals x, and then you end up with what's called its inverse graph. Now, this is the inverse graph of x squared. It is called square root of x. Now, what's the problem though? Do you remember what we said about functions?
If it has more than one x value, it's not a function.
Right here, graphically. Do you remember what we said about functions? Like this one's okay on the left, but this one's bad. The vertical line test. I want you to take your pencil and I want you to make the part of the graph that is acceptable bold. And then the part of the graph that is not acceptable will just stay thin. So in college algebra, we talked about how some graphs, when you take and flip them over the line y equals x and you graph the inverse, you have a problem. We have a problem. This doesn't pass the vertical line test. So we started talking about how you have to restrict the domain. You basically say to yourself, as long as you don't plug a negative number in here, then you're okay. And that's where the graph of the square root of x actually is just this, right? It's just that. That didn't curve very well. Let me try again. It's actually just this portion because they've restricted the domain. So what we're doing, the reason I'm showing you all of this is because we're fixing to look at the graphs sine, cosine, tangent, and we're going to find their inverses, which mean inverse sine, inverse tan, inverse cosine. And we're going to talk about how when you find the inverse on the graph, you run into a problem, which takes us to the next slide. The next slide, and I already have everything up here. We'll leave it alone. I have shown you, I want you to take your marker or pen or pencil and basically group these top ones together and label it as the mother functions. Then group these bottom ones together and label it as the inverses. It's up to you. So you can see like mine. I just boxed it in with pencil, but you could do highlighter if you wanted to. Yeah, the next slide's the one where you're actually going to highlight a bunch of stuff. So the top three graphs are reminding you of the mother functions for sine, cosine, tangent. These should look familiar. Remember we said roller coasters, best part's when you start up high. Remember when we used to talk about how cosine starts at 1, 0, 1, and sine goes through 0, 0? And then, of course, tangent's the weird one where it's like there's different lines for tangent.
I don't know.
So these are the three graphs that we have already covered. We've practiced graphing. Those are sine, cosine, tan. Here are the three inverses. So notice what they did. Reflecting over the line y equals x. Notice right here, this says x equals sine y. Up here it said y equals sine x. They took x and y and they switched them. And then they graphed it. What do you notice not one of them does?
Passes the vertical line.
Not one of them passes the vertical line test. That's the takeaway here. Which is why I want you to say fails the test. Fails the vertical line test. Not one of these graphs passes the vertical line test, which means, this is where you might be like, they could have just left it alone. You know, I can just see it now. The math meeting of the nerds got together and they said, hey, none of them passed the vertical line test. And someone in the meeting should have said, that's it, put a stamp, we're done, and we'll just call it a day. And then no, someone was in there and said, well, what if we just restrict the domain to right here, and then now we can explore it? And that's what we're fixing to do. So basically, we have these graphs here. We can do nothing with them because they failed the function test. So, because of that one person that sat in the meeting that day, we're going to focus on just a little segment, a snippet. And those are not accurate, so don't draw those. But basically, we're going to zoom in on a snippet of the graph that does pass the vertical line test so that we can do math with it. Or we could have just left it. Or we could have left it.
Yay!
Someone in the meeting should have said, nope, leave it alone, put a period, close the book, we're done. It's exactly like when someone said, let's take the square root of negative numbers. Let's just call it an I. You know, there's a whole new world of math now. Okay. Are y'all good with this? Can we change the...
Nah, I'm still taking notes.
No, you're not. All right. Go to this slide. Don't get overwhelmed. Hold on. Don't get overwhelmed.
How does that say memorize?
There's a lot here. Let's direct your attention up top left. Inverse notation. This is something new. It's very similar to, let me go back to the first slide. Remember we said the inverse of a function is f and then a little -1, right? That doesn't mean an exponent of negative 1. It just meant the notation f inverse. Okay, same thing with sine, cosine, and tangent. If you're talking about the inverse, it has a little -1 in what looks like the exponent's place. Now this one's new. Or you will literally see the word arc in front of it. It'll say arc sine. And it means sine inverse. Or you'll see arc tan, arc cosine. I'll be honest, I don't use arc. I don't know why. I always did the -1. But if your next math class, which would be Calc 1, if you're going into a major that requires you to take Calc 1, you might see arc, because college textbooks do use the word arc more often than the -1. I don't know why. I don't know what's so wrong with the -1. I see nothing wrong with it. But anyways, so there you go. You've seen it. Okay, now here's where I do want you to highlight. Try to highlight exactly like I did. Because what I'm doing is I'm saying, hey, remember this whole graph here? We're only going to look at the highlighted green section. Let me see if I can make this bigger. Look at that. There you go. We're only going to look at the highlighted green section of the graph, and that's what we're going to explore so that it passes the vertical line test. It is pointing at this dotted line right here, reminding you that there are asymptotes in the tangent graph.
What?
What did you say I have to do? I have to get the lactic acid out? Is that what causes soreness? I don't run, so can I just move in place?
Stretch it out. But it takes longer, it probably hurts more.
I do need a walking pad. I could be standing right here
Exactly.
and like walking. Somebody get hurt on it. All right, so this is sine, this is cosine, this is tan. The highlighted green section is showing you what we're going to focus on. So this is good news. Where you have this whole giant curve, we're now just focusing on this little snippet of the graph. Okay, direct your attention over here. let's refresh your memory on domain and range. Domain is what are the x values covered by the graph. Range is what are the y values covered. Now I highlighted it because what's going to happen is when we start getting into, we're going to solve trig equations in the next section. And so we need to know when we solve trig equations, when we come to an answer that is not actually in the domain or range so that we can throw it out. So that's why you have to know this. Look at your formula sheet. Look at the brand new formula sheet I gave you. You'll notice it is very crowded because there's already a lot on the mid. Go to the bottom, at the very, very, very bottom. You see those two, what looks like bullseyes, kind of? And then do you notice that there is a thicker, darker section, like on the bottom left
Yes.
picture? The right side, quadrants 1 and 4 look bolder. And then on the bottom right, quadrants 1 and 2 look bolder. Do you notice that? That's me letting you know what quadrants you're allowed to pull an answer from for those specific trig functions. Look, it's even labeled for you. It says, for that bottom left picture, the range of sine inverse, tan inverse, and then it even gives you the reciprocal ones, runs from negative pi over 2 to pi over 2. So I'm giving you the range that's listed right here. Okay, so you don't have to memorize this, but you do have to memorize how to read it. Like what, I can look at it all day long. If I don't know what it's telling me, it's useless. Let me explain over here where these came from. Domain means the x values. What are the x values covered by sine? Our highlighted section runs from what to what? What's the lowest x value? -1 to 1. Now turn your head sideways. Turn your head sideways. What's the lowest y value? You turn your head sideways. It's running from negative pi over 2 to pi over 2. You see that? That's where they get those answers. Come into cosine. What's the x value? It's running from -1 to 1. Turn your head sideways. The y value is 0 to pi. Come over here to tangent. The x's, they have arrows, which means keeps going. All real numbers on the x's. Turn your head sideways. It's oscillating between negative pi over 2 to pi over 2. It's not labeled, but if this is negative pi, then this is halfway. Okay? I'm going to show you how to apply that when we get to the example question. Come down here. This down here is where I have pulled these three graphs. Focus your attention up here, which looks like little purple caterpillars. I've pulled these three graphs. It's time for me to zoom out. Hold on. The three green highlighted graphs right here, I have copied them here without all the noise. You with me? So these three purple caterpillar graphs here are what we highlighted here. Just I took all the noise away, all the extra stuff. Then underneath it, I have shown you what the domain and range, it's actually the range because that's where you're producing your answer. So these three graphs right here are showing the ranges of the three trig functions, meaning what our possible answers can come from. So when we solve these trig equations, stay with me, Brody.
Sorry.
I can only pull sine, this is sine, from quadrant 1 or 4, right? This is cosine. I can only pull from 1 or 2. This is tan. I can only pull from 1 or 4. You might want to also draw an arrow to emphasize that on the tan inverse range, those are open circles, meaning it doesn't actually touch it. So for instance, coming up here, you have parentheses, but you probably can't see them very well, so you might want to even emphasize that those were parentheses, meaning it doesn't actually touch them. All the others are brackets. Now, I wrote memorize here because I used to scare people into saying, like, you got to memorize this, and we actually came up with a way to memorize it. But in the end, I ended up putting it on a formula sheet. So I've since decided to quit scaring you. But I am going to say memorize. I'm going to leave it there because you need to be, familiarized. You need to be able to look at this and to know what it's telling you. You probably don't know yet because I haven't practiced a problem with you. But when we get there and practice a problem, then you should be able to look at this and know what it's actually telling you. Okay? All right, that's enough talk. We have 2 slides of practice problems, and then we're calling it a day. Is everyone finished with this slide? Okay. Go here. Ignore that. Ignore all that. Please. All right. Look at the staircase. One step. You do want your unit circle. So either use the formula sheet I just gave you or get your blue unit circle out.
Like a blue sticky note?
Gum.
Dang it! My gum's in the truck.
Alright.
I'm going to use it.
So it says find each of the
Just hold
following
it. I can't do it.
functions.
I'll put a sticky note on your back.
It
I
just
keep
fell off.
laughing so much.
It just fell, but it's been there the whole class, and me and him have been dying.
You can't find me.
That's what I was doing with that thing when I was rubbing your back. I was putting a sticky note on there.
Oh, I thought you were just trying to like pinch me.
No, I was putting a sticky note on there.
Hope I typed your grade in right.
I hope so.
Okay, look here. Let's see, let's dive into the practice problem. It says find each of the following values. All right. Let me back up. Go to your unit circle. Ready? Everybody look at it. I have to look at it too because I don't off the top of my head. Everybody put your pencil on sine of 5 pi over 6. Sine 5 pi over 6. So your pencil should be at 5 pi over 6, and you should be on which one? Siny, the y, right?
Don't go to college.
Which is 1/2. Now put your pencil on cosine of 3 pi over 2. Cosine means you're looking at which one?
Don't go to college.
X. Don't go to Costco. It's $400. All right, and then tangent meant you had to actually take and divide what by what?
Y by X.
Tangent meant you had to divide y over x in order to answer tangent. Okay, what you just did was answering sine, cosine, tangent of a given angle in radian. Now what we're going to do is we already know the answer. We're going to work backwards to get what was the radian. So this is saying, hey, the y-coordinate of some angle is root 2 over 2. Well, I want you to look at your unit circle. How many root 2 over 2 y values are there?
1, 2, 3, 4.
Actually, let me pull my unit circle up here. Because that would help. Which one was that? 6. Chapter 6. Here we go. Okay. How many, let's get a decent color. How many y values are root 2 over 2? We got that one.
1.
That one. That's negative. That's negative.
2,
So we have 2.
don't.
See that? here. This said which one? Sine, cosine, or tangent?
Sine.
It said sine. Go back to the last slide. The sine inverse is only allowed to pull answers from what quadrants?
1 or 4.
Ah.
So it'd have to be
So coming back over
pi over
here,
6.
which one cannot work then?
The left side.
This one is not, I meant for that to be really dramatic. This one is not applicable because sine inverse, here's that green highlighted thing. This is where it's kicking in, hopefully. What we highlighted on sine inverse was that it runs from here to here. So now the overlap of where sine inverse is allowed to answer from and where I actually see a positive root 2 over 2 as a y-coordinate tells me that it was pi over 4. That's good. Let's remember that. I was going to say but we'll wait till we get there.
But.
There is well, it's not really a but. There's a what if. Now you can see how to answer this. It's not enough to just come over here and write pi over 4 because as you're doing your practice problems or as you're studying for this exam, if you just look at this and be like, how in the world did I get pi over 4? So we're going to take some notes. So everybody, suck it up, Buttercup, and take some notes. Sine, whoops, hold on. Can't tell when I'm writing what it's. Here we go. Sine means pull which one?
Y.
Y. Cosine means which one? X. Don't go to Costco. And tangent means which one?
X, Y over X, sorry.
Y over X. All right, so that's something you've got to remember. And then now let's come over here, and we're going to say to ourselves, this is a sine inverse problem. You're going to go to your formula sheet, look at your formula sheet, and see where is the bold sections, the 2 quadrants that are in bold, to tell me where I can answer from. And you're going to copy it here to here. That's the bold sections, right? And then, now here's where the what if comes in. It's at the bottom. Yeah, that's it. Now, this, you do need to remember this is negative 90. This is not 270. That's the what if that's going to come into play soon. That's negative 90 to 90. That's not 270 and then counting back to 90. So be careful. It is quadrants 1 and 4, but it's negative 90 to 90. All right, now we're going to take notes right here. You won't have to write this again if you don't want to, but I will write it in case you want to take very thorough notes. What, don't write big, angle has a y value of root 2 over 2 within sine inverse range. So this is the question you would ask yourself as you're doing this problem. You would say, what angle has a y value of root 2 over 2 that is within my sine inverse range? Now, we've already answered it. We said it was, answer that here. Sine inverse of root 2 over 2 is pi over 4, or what is that in degrees?
45.
Or 45 degrees. All right, let's do cosine inverse negative 1/2. When you first start the problem, I would take and copy the range you're allowed to answer in. Look at your formula sheet, go to the bottom, find the one that fits cosine inverse. Did you get 0 to 180? Or you can answer 0 to pi, either one. So this tells me that I'm only pulling an answer from either quadrant 1 or 2. Well, if sine is negative, cosine, sorry. If cosine's negative, then which quadrant am I going to? Out of my 2 choices. 2. So you're going to go to your formula sheet. We said our approved section section is here to here. We are looking for when x is negative 1/2. There it is. So it's 2 pi over 3 or 120 degrees. So I like to take thorough notes. I'm going to say cosine inverse of negative 1/2 is 2 pi over 3 or 120. Now watch this. Take your calculator, put it in degree mode.
Calculator. Mode. Degree.
Now type cosine 120. I bet you get negative 0.5. You can check yourself.
Oh.
Because what you're doing is you're just reversing it. I'm like, that came out there. So you're just reversing it.
Oh.
Where we used to say, what is the cosine of 120? You would go to your unit circle, you'd find 120, you'd pull the x. We just reversed what we're asking. We're saying, hey, the cosine of some graph is negative 120. Can you tell me what the angle measure was? Negative 120, negative 1/2. No, there's one. Oh no, that is all. The next set of examples is when they're not pretty. So these are actually these are easier because you just type in the calculator. Let's do tan. You know how tan is. Here we go. All right, let's copy our range to let us know what we can answer in. Tan, if you go to your formula sheet, find tan inverse. It's negative 90 to, oh, not open, you're not closed. Negative 90 to 90, right? All right, let's lay it out carefully. Copy the question. What angle has a tan value? Now, what is tan again? Which means, I'm going to come right here, which means y over x of negative root 3 over 3 within tan range. So it's a big question. What angle has a tan value, which means y got divided by x, of negative root 3 over 3 that's within the tan range? Now, a couple of ways you can approach this. One way is to know where's tan negative. So remember, tan is where you take y and divide by x. The only time you can divide two numbers and get a negative is if one of them's negative, right?
All ships transport cargo.
Yeah, those are the ones that tell you which ones are positive,
So
right?
it'd be 2 and 4 that 10 would be negative.
So let me highlight first. What's the random B right there?
B for Brody.
That's so
All right. Let's highlight the range that we're allowed to answer from. I am putting an open circle right here. Okay. And now let's highlight. Maybe I'll do a bright green. Where's tan negative? Well, in quadrant 1, tan's positive because that's positive divided by positive. Tan's negative here, right? Negative tan. Positive. What about here?
Negative 10.
Negative 10. So now we know that we're answering from here because this is where tan is negative. Now you look at what you actually needed. You needed root 3 over 3. Do you remember you were supposed to have this memorized on that last exam? We said to make your life easier, remember that tan of which one? Of 30 is the one with more 3's. Root 3 over 3. Remember that? And we said then tan of 60 is the one that's just root 3. So now we know from memory, without having to recreate, you could sit here and re-divide y by x. I would not want to do that. I would want to say to myself, I know tan of 30 is root 3 over 3. Now I'm in quadrant 4, so you're going to go to the one that has a 30-degree reference angle.
It'd be 300.
Which one has a 30-degree reference angle?
300.
30-degree reference angle?
330, sorry.
Be 330, right? 330, when we say 30-degree reference angle, we mean there's a 30-degree gap right here from the angle to the nearest x-axis. So tan of 330 would be negative root 3 over 3, right? What is it as radian? 11. Okay, all right, we have one small problem. Can anyone tell me, Houston, what's the problem? So we got tan, negative, oh, it's negative. I'm writing my notes, hold on. Equals, we said 330. But look at your range. Your answer needs to fall between negative 90 to 90.
It'd be negative 30.
So it's negative 30. Does that make sense? 330 is not within the acceptable range. It needs to read from negative 90 to 90. So it's still, that doesn't change the location of the angle. The angle is still right here. Right here is the angle. It's just a matter of, instead of saying you went all the way around and landed at 330, you got to stay in the green. You're saying you started here and you just went backwards negative 30. So it's negative 30 is the correct answer, okay? And that was the one thing, so if you need to make a note to yourself, you know, it was, what is it, open, negative 90 to 90 is what you had to keep in mind. So we adjust our answer to say, hey, it's negative 30. This is the only one that's a gotcha. It's not really a gotcha. It's the one that involves more work. If you go, it's a great question. If you go to those quadrantal angles, what is the x coordinate at these? And in tan, where does x go? At the bottom, and you cannot go to the beach without your bottoms, right?
Huh?
Someone took Kayla's phone and Snapchat.
Not supposed to.
I hate black people.
Some people have kids. Don't put your eggs in the bottom of a grocery basket.
Unless they're by themselves.
Okay. How about no? It's a no-go when zero's in the bottom of a fraction.
Or you go to a new beach.
So that's why it's an open circle, because if you were to find a tan of pi over 2 or 3 pi over, not 3 pi, negative pi over 2,
Nah.
you're going to get an error.
More like
That's why.
nut beach.
All right, now come down here to the bottom. This is going to be a breath of fresh air, because this is, what if they're ugly? Well, then you literally typed in
Yes.
You do need to make sure, however,
You're in the green one.
Can we do that
Oh my
first,
gosh.
please?
You need to make sure, let's see, mode
Degree.
needs to be degree. It is asking for 4 decimal places.
Round radian measures 4 decimal places and degree measures to the nearest 10.
I just went to, so what I did was I found the degrees on all of them, and then I multiplied by, there's like 3 different ways you can do this. You can find the degree answer for all of them, then you could change to radian and find the radian answer. I just found the degree answer for all of them, and then I just converted the degrees to radians.
Which is
If I'm going to
pi over
radian,
180
you multiply by pi over 180.
times.
So like number 1 says cosine of this decimal. Oh, I don't have my calculator up. Hold on.
Came to class unprepared.
Well, not
Wow,
really.
Miss Holcombe.
Not really. It's right here. I'm prepared.
Oh, that was your song in class.
All right. What's mine in? Mine's in radian. Let me change it to degree. Okay, clear. All right, cosine inverse of this decimal. So I'm going to do second. You have to hit the second button. Cosine. We got negative 0.2689. So it's a 105. It says radians to 4, degrees to 10. So 105.6, right? So what I did was I said, there's my degree answer, and then I multiplied that by pi over 180 to get my radian answer. So I was only finding the actual true value once, and then I just converted it every time. So I'm going to draw an arrow that to go from degree down here in radian, you would multiply by pi over 180. You are going to 4 decimal places, which means you check the 5th one. Alright, so B, did you get negative 14.7 degrees? And that for radian? Alright, here, did you get 11.7? And here, remember, you got to get comfortable being uncomfortable with ugly answers, because we're definitely there. So please don't look at an answer and be like, that's not possible. Yeah, in radian it is possible. D, we got undefined. E, you should have said, so if you need help with E, you would ask yourself, what angle has a cosecant that's equal to, what is the decimal? 8.205. What does cosecant mean, y'all? 1 over sine. Well, I don't want to write 1 over sine because then in my calculator I have to do 1 divide sine. So if I write it as sine, do you remember this? I can instead of putting my fraction here, I can put it over here. So I can put this as 1 over 8.205. Now that's just one way to do it. You can do it a different way. You could do 1 over sine. But I want to be able to do sine inverse. My finger touched. I want to be able to do sine inverse of the fraction. So I'm going to do sine inverse of that. And did you get this? Degree 7?
We're about to, but we all got undefined the first time.
Now, go to the next slide and everybody do the 6 practice problems. Now, that you should find them to be faster than the decimal questions. I found the calculator section to take longer. Use your unit circle. Remember, next to each one, copy what your answer can come from. So, like the first one, sine inverse of negative root 3 over 2. Well, sine can run from negative 90 to 90. Sine runs from negative 90 to 90. So go to your unit circle and only pull an answer from either quadrant 1 or 4. Since it's negative, that's telling you to go to which one? go to quadrant 4. We're looking for negative root. So here's our area of where we can pull an answer. It's negative root 3 over 2. So it's 300. There it is. But 300 is not acceptable, so it would be 300 has what reference angle? If it was in, if you started here and rotated down, it would be negative 60. So it's okay to say to yourself, you know, that it's 300, but dot dot dot, it's actually negative 60. Now they want radians and degrees, so degrees are easier. If it's negative 60, then just come up here to 60 and look at the radian. It'd be negative pi over 3. Let me say that again. We said it's negative 60. Go to the 60 to get the equivalent radian measure, but it would be negative. So it's negative pi over 3. So number 2 says find tan inverse of 1. Well, if tan is, I'm going to draw an arrow and draw a plus sign. If it's positive, and then keeping in mind where tangent is allowed, like the range is allowed to be pulled from, then which one am I actually in? Quadrant 1. Tan is positive here. So I'm going to go to quadrant 1 and I'm going to ask myself in quadrant 1, when would I divide y over x? So take notes here. You're saying to yourself, when y divides by x and gives me 1, what is the angle? And it would be 45 degrees. Does that make sense? So they're not challenging, but they do have several trains of thought, which we talked about how that's how this whole class is. It's not that we are like, yeah, we're doing challenging stuff, but we're doing stuff that has like 4 or 5 trains of thought instead of what used to have 1 in normal high school math. And some of your trains may be, you know, on fire, going off the rails down here. But that's okay. We're going to get there. All right, you try those last 4. I'm going to put the answers and you just see if you got them right or not. Please don't just look up here and copy it down and say, okay, I'm done. Don't do that. Because then when we take the next exam, you're robbing yourself of the opportunity to know it.